Hey everyone. So lesson 2 in our trig unit, we're going to take a look at the derivatives of sine and cosine. And really, it's not super complicated. I just got to tell you what they are, and then we're going to work with them just like we'd work with any other derivative. Okay, so to do that though, what I'd like to do is here I've given you and in your book, I've given you the graph of sine x, and we want to figure out the derivative, okay? So we want to graphically look at the derivative. Now, you could draw a sketch of this, and that would be fine, but what I want to do is I actually want to walk you through doing it with your graphing calculator for a sec, because I want you to see something very specific. And if you just draw a sketch, you may be off slightly on your sketch and you may not see what I want you to see. So what I'm going to do is I'm going to switch my screens to a graphing calculator. So just give me 1 sec here. Okay, and then what we're going to do is we're going to write in y1 sine x. Okay, and then in y2, I'm going to write the derivative of y1. Now to do that on a Casio, we go option, calculate, and then derivative is that first guy there. So now it says d over dx, and then in there, I'm just going to say y1. So I go f1, 1, and I hit graph, okay, or draw. Now, tell me what you see. What I want you to see there is that's actually cos. Okay, the derivative of sine x is cos x. Okay, so now I'm going to unshare or switch back to the PowerPoint slide. Okay, and we're going to just put that right here. And we see that the derivative of sine x is cos x. Okay. All right. The next guy we're going to take a look at is the derivative of cos x. Now, it's not sine x. Don't get too excited. But we're going to do the same thing. So I'm going to switch graphs or switch to my graphing calculator. And I'm going to just change my y1 to be cos x. And I don't actually have to do anything to my y2 because it's still just the derivative of y1. So you've got your blue graph being cos x. And now I want to take a look at that red graph, which is the derivative. Let me give you a slightly better window. Let's go, let's just go negative 3.14 to 3.14. And let's go maybe negative 1.5 to 1.5, just so you can see that graph a little bigger. Okay. All right. So what do you see here? You're starting on a midline and heading down and then up. That's actually negative sine. Okay. That is negative sine. So let me switch back. Okay. And we have derivative of cosine x is negative sine x. So the derivative of sine x is cos x, and the derivative of cos x is negative sine x. Okay, so I'll give you a sec to fill that in. And then really all we're going to do today is work with these principles as we calculate some derivatives. Okay, so first guy, what's the derivative of sine of 3x? Now, right away, I know we maybe have not done different sorts of derivatives for a little bit. Right away, I need you to see the chain rule there. Okay, so I'll be taking the derivative of the outside function and multiplying it by the derivative of the inside function. 3x is a function inside sine. Okay, so the derivative of sine x is cos x. So that's going to be cos 3x. And then the derivative of the inside function is 3. Okay, so that ends up being 3 times cos 3x. Does that make sense? Okay, so it's just the chain rule there. Okay. That first one was too easy, right? Okay, so f of x equals 4 cos of negative 2x squared minus x. So again, the first thing I need to see is 4 cos of something. So the derivative of cos of something would be negative sine of that something. Then I have to take the derivative of the inside function, which would be negative 4x minus 1. So I have, now I just want to, this 4 cos of something became 4 negative sine of that something. Okay, I don't want you to get confused where that 4 came from. The 4 was there originally. I just left it in the front as a coefficient. Okay. Now the derivative of the inside function is negative 4x minus 1. Okay, so now we're going to clean this up. Couple of things we can do. I can take out this negative here. I'm just going to take off the ink that I had, just so I can start talking here. I'm going to take out this negative. Okay, and then this is going to be, I can take out a negative from here. And those two negatives being multiplied together will give me a positive. So that's going to leave me with 4 times 4x plus 1 times sine of negative 2x squared minus 2x. Then 4 times 4x plus 1 I can write as 16x plus 4. Okay. All right, good. Next guy. Again, I've gotten more complicated for sure, but remember that it's just like I'm taking the derivative of different terms, right? And when you have different terms and you're taking the derivative, you take the derivative of each term. So I need to take the derivative of this guy. I need to take the derivative of this guy. And I need to take the derivative of this guy. Well, this guy's just a number, right? Pi is 3.14 whatever. So the derivative of that is 0. Okay, let's take a look here for a second though. I need you to see this is sine x squared all to the 4, right? So there's essentially 3 layers of chain rule here. I have to deal with the outside exponent of 4, I have to deal with the sine of something, and I have to deal with the x squared. Okay. So I just wrote this with that 4 on the outside first, just so you could see it a little bit visually. And then we've got these 3 layers of chain rule there, and then the sine of x squared, and then the x squared itself. So if I do that, the 4 is going to come to the front, so that'll be 12. And then this will be sine x squared to the 3. Okay, that's the first layer. Then I go inside. Sine of x squared would be cos of x squared. And then the x squared would be 2x. Okay, then I got to do the same thing over here. So the 5 is going to come to the front. So that'll be negative 10 cos x cubed to the 4. Then cos x cubed, the derivative of cos x cubed would be negative sine x cubed. And then the derivative of x cubed would be 3x squared. Okay, so that's what's happened here. Again, the 4 came to the front, that's what gave me the 12. This dropped a degree. The derivative of sine x squared is cos x squared. And then the derivative of x squared is 2x. Here, the 5 came to the front, that's where the negative 10 came from. The derivative of cos x cubed, oh, sorry, and then I dropped a degree, I didn't say that. I dropped a degree, that's the 5 moved to a 4. Then the derivative of cos x cubed would be negative sine x cubed. And then the derivative of 3x would be 3x squared. Okay, so now I want to work on just cleaning this up a little bit. So first thing I'm going to do is just multiply my 2x and 12 together and my 3x squared and minus 10 together. Okay. And then I can take out a 6x. There's a 6x that's common to both of those terms. And so I've done that. The 6x comes to the front. And that leaves me with 4 sine cubed x squared cos x squared. And then I have 5 cos x cubed to the 4, which is cos 4 x cubed, and sine of x cubed. Also take note here, this negative times this negative here. I don't know if you can see my mouse circling there, so I'm just going to highlight that for a sec so you can see it. This negative times this negative gave me this positive. Okay. Awesome. That was the hardest one today. So if you can handle that, you're golden. Okay. Okay. Then we have x squared over sine x. And I need you to see, like you've always seen for the last couple of months, this is going to be the quotient rule. Okay. So I've got the derivative of f times g minus f times the derivative of g over g squared. Okay. I simply use the product rule. The only difference, or sorry, the quotient rule, the only difference here is I'm dealing with trigonometric identities at the same time. So I had to remember that the derivative of sine is cos and the derivative of cos is negative sine. So now I'm going to factor that x out of the top, and that would leave me with x times 2 sine x minus x cos x, all over sine squared x. Okay. All right. So your homework has been posted here. And as always, if you have any questions, make sure you get in touch with me. Okay. You guys got this. Take care.